We're now going to discuss what's called discrete probability distributions. So first, exactly what is a probability distribution? A discrete probability distribution is just a table that's going to consist of discrete variables and their probabilities. And the key is that we need all possible probabilities. So if I add up all of the probabilities in the table, they should add to be 1. So let's look at a couple of examples. Let's consider rolling a die. Probability distributions have 2 rows or columns, depending if you do horizontal or vertical. One that's called X and the other is P of X. X is your possible outcomes. Well, we could roll a 1, 2, 3, 4, 5, or a 6. And then P of X is the probabilities. If we roll a fair dice, each one of these has the same chance of occurring. So 1/6 all the way through. So this is our probability distribution for rolling a single die. My next one, I want to look at the number of heads on 3 coin tosses. I need to have a discrete variable, so I need to be able to count this. So in my case, on my 3 coin tosses, I'm going to count the number of heads. I have X and P of X. And now I can think of how many possible heads could I do. I could get 0, 1, 2, or all 3. Now we have to think of the probabilities. Well, let's think of all the possible coin flips. I could do 3 tails, 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 heads, tails, heads, tails, tails, heads, heads. I could also do HTT, HTH, HHT, and HHH. So if I want to consider 0, I just have one option. So 1 out of the total of 8. To get 1 heads, I have 1, 2, 3 options, 3 out of 8. 2 heads is 1, 2, 3. And then a single head is, or 3 heads is 1 out of 8. So now I have my probabilities, and if we add them up, they add to 1. Let's do one more example. Here I looked at a total of 200 students, and I asked them how many tattoos they had, and this is my result. So now I want to do a probability distribution. If I choose a student at random, what's the chance they have a certain number? Well, my X is going to stay the same, 0, 1, 2, 3, 4. And now P of X is probabilities. So my first one, 170 divided by the total of 200, 85. 24 divided by 200 is 12. 3 divided by 200 would be 0.015. 2 divided by 200 is 0.01. And then 1 divided by 200, 0.005. So these can be written in fractions. They can also be written in decimals. So now that we've done that, let's talk about a couple of other things that we can find from these tables. The first thing I'm going to look at is trying to find the mean. And I find this by taking the summation of X, P of X. What this means is I'm going to multiply my discrete variable X times its probability, and then I'm going to add all of them up. And this is also known as expected value. Now that we have that, let's talk about the next thing, which is standard deviation. This is a little bit more complicated, but we can still do it. We're going to subtract the mean that we just found from each of our data values, square that, multiply by its probability, and then add them up. And then we'll take the square root. So now that we have our formulas, let's work through a couple of examples. Here was our probability distribution for rolling a die. And whenever we're doing this, we're just going to add a few columns onto this table. My first one is going to be X, P of X. Just multiply these two values. This is 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. And a lot of times this is going to be helpful to leave it as unreduced fractions. Now to actually find the mean from this, we're just going to add up all of these numbers. And when we do, we'll get 21 over 6, or equivalently 7 over 2. Also 3.5. The reason it's helpful to not reduce these fractions when we multiply is because it makes this addition much simpler. Now let's try to find our standard deviation. For that one, I'm going to need a couple of more columns. My first is going to be x minus mu, 1 over 6 minus my mean, which was 7 over 2. Our final column, although I'm running out of room, would be to multiply this number by probability. So 6.25 times 1 over 6. Roughly 1.04. 2.25 times 1 over 6, 0.375. 0.25 times 1 over 6, 0.041 or 042. Same thing here. This is 0.375 and 0.104. We then need to add all of these up and take the square root. So when we do, so first adding them all up gives me roughly 2.917, and then when I take the square root of that, 1.708.